Welcome everyone to Fundamentals of Lighting in Unreal Engine 5. This is going to be a big subject, probably going to be quite a few videos covering this, but it's something that I'm really excited about, and it's something that I feel like is somewhat lacking in tutorials. There are a lot of lighting tutorials out there, but a lot of them are geared more towards cinematics or renderings and things like that, and not always maybe the best advice for how to light a scene or areas specifically for games when you're making a game. And then the ones that are out there that are showing you how to light for your game, I feel like they're often a bit incomplete. So I want to do the best that I can to really give you guys a full picture of how to light different scenes and how to do it in the best ways possible. Now, I also want to just put a disclaimer out there first and just say that I am by no means an expert. I do have about 15 years of experience in photography. So I have a lot of experience with real world lighting, both natural light, outdoor, studio light, a combination of natural light and artificial light. But when it comes to the actual engine, I have like 2.5 years of experience with that. And even with lighting in the engine, I would say that I have even less, because while I have studied a lot of different lighting techniques, like probably many of you, I, started searching for tutorials and found a bunch that I'm realizing now are maybe not the best way to do things. And then also, I just want to say that, there's a lot of kind of artistic interpretation when it comes to lighting. And so certain ways that some people may do it are not necessarily the wrong way. There are just different ways to approach this. And so I want to try and give you guys just the best approach that I have learned and the best approach that works for a variety of different scenes. And I also really want to focus on using real world physically based lighting values. I think that that's really important that not a lot of people will cover. So I think without further ado, let's just go ahead and jump in and let's get started. All right, so before we get into creating a new level, adding any lights or anything like that, I want to just go over some of the settings really quick. So if we go to project settings, also, by the way, I am using Unreal Engine 5.5.4, I believe. So there may be a few things that change in the future as Epic updates and sometimes removes or adds new features. But for the most part, we're just going to stick with fundamentals, and that's not really going to change too much. So I do want to just go over a couple of things in the rendering tab. If we scroll down, so really we're going to leave everything pretty much on defaults because everything is fine here. But we have our global illumination is going to be set to Lumen. We will be using Lumen for the most part. I will go much more in depth on what Lumen is and how it is useful, the drawbacks to Lumen, how to kind of overcome some issues that Lumen has and things like that. But for pretty much everything, we're just going to leave this on default. Let's see. By default now, I think that this used to be unchecked, but it looks like on the default settings, use hardware ray tracing when available is checked to true. If you are noticing any issues, or if you maybe have a slightly older computer, you can uncheck that. I know that there were some issues in the past where it would try and use hardware ray tracing and would kind of slow some things down. So that's an option that you could turn off. Another thing that you could change is the software ray tracing mode. You could change that from detail to global tracing. This will be a faster way of calculating the software ray tracing, but it is not going to be as accurate. So keep that in mind. Let's see. We're not going to turn mega lights on right now, but I will talk about that in the future. It's something that Epic has just put out. I believe it literally just came out in 5.5, and it is still very much experimental. It even says here it is an experimental feature. So we will not cover that at the moment, but I will go over that in the future. As for ray traced shadows, we are going to just leave that off by default. I should also say all of these settings can be changed, or most of these settings can be changed in the engine using the post-process volume as well. So things like ray traced shadows, these are much more accurate shadows, but they are much heavier on performance. So I like to leave that on. I like to leave that off by default, and then we can pick and choose when we want to have ray trace shadows. And then by default, we're going to be using virtual shadow maps, which is fine. Let's see. I will have support for hardware ray tracing ticked, just because we might want to use hardware ray tracing. Let's see. Pretty much everything else is just fine. By default, Unreal Engine 5 has allow static lighting unchecked. So if you did want to do any baked lighting, then you would want to check this, and I believe that requires a restart of the engine as well. Let's see. I think, so I do want to change this. So on our light units here, by default, it's set to candelas. I'm going to change this to lumens because we're going to be using lumens as our values for our lights a lot more. And these, we'll get into this in the next video, but we'll be using physically based lighting values, which basically just means that we're going to be using real world numbers. So like if you find a light bulb, if you go to the store and buy a light bulb, you can actually see it will be something like 800 lumens or something like that. So changing this to lumens will allow us to use real world numbers and just make that a little bit easier for us. Let's see. I think that is everything. I do just want to see if I look for luminance. Okay, good. So I think this was a thing that they changed as well. This used to be off, but what I want is extend default luminance range in auto exposure settings. I want that to be true. This used to not be checked, and basically what would happen, because we're going to be using real world values for things like the direction light, the actual values of the sun are crazy high, like 100,000 lux. And by default, the engine used to not let you set some of the values that high unless you had this checked. So it looks like it is checked by default now, so that's good. So yeah, I think we are pretty much set on our project settings. I think really the only thing we changed was just the values, or the units that the lights are using. But I wanted to just go over a couple of other of these settings to just mention some of those things. So with that being said, let's go ahead and create a blink level for us to work in. So I like to always just create a folder here called 01 my contents, just so it shows up at the very start here. And then I'm just going to create another folder for maps. And we're going to do a new level. We'll call this lighting test. Open that up. All right, so here we are in our newly created level that is completely blank. And one thing I always like to do, this is totally just a preference, but I always like to turn this grid off just because it kind of gets annoying whenever I put a mesh in here. And I am going to go into, I downloaded the starter content so that I can just have a few different shapes and things like that. And I'm just going to grab this floor, drag it in, and make this a little bigger. Okay. And then let's also just get a shape of some kind. Let's see what we have here. Let's just use the sphere. Okay. All right, so now we have a completely blank scene with just two meshes in here. And I am going to, by the way, I'm toggling this on and off, the lit versus unlit. I'm doing that with Alt 3 and Alt 4. Alt 4 is lit, Alt 3 is unlit. So I'm going to go into lit mode, and obviously you can't see anything because we don't have any lights. So let's talk a little bit about the lights that we have access to. So we go up here to add, and you can see that we have 5 different lights. We have the direction light, point light, spotlight, rect light, and the skylight. Now, for right now, we're just going to focus on these 3 lights, and we'll get to the directional light and the skylight in a bit, but I want to just focus on these because these are going to be the most common that you're going to be using. So if I just drag a point light in here, then you can kind of see right away what is going to start happening. And this is pretty self-explanatory, but a point light is just a single point that is spreading light out in every direction. Now, one thing to know with a point light is it is quite expensive in terms of performance, especially when we have shadows on. Essentially, what a point light is it's a spotlight that has, or it's 6 different spotlights. One that's going out this way, one that's going out this way, this way, this way, up and down. So it's basically a series of spotlights that's going out in every direction. So that means that it is 6 times more expensive in terms of performance than a spotlight. Okay, so keep that in mind. Let's go over here and let's kind of look at the details of this. Now, the first thing that you'll see is our intensity. Now, if you remember, we changed the units to lumens, and we'll talk more about this in the future, but for right now, just know that the intensity, the larger you make this, the brighter it's going to get. The lower you make this, the softer the light's going to get, and so on. Now, you're probably noticing that as I make this brighter, I can actually make this as bright as I want. If I set this to something like 10,000, then we have this auto exposure going on. So, even if I go back to 100, the auto exposure is going to pick this up, and it's going to try and balance this out to where we are seeing roughly the same version of the light that the camera or the engine wants us to see. So something that's important to think about is think about the viewport here is basically a camera that we are looking through. And this camera by default is set to use auto exposure. And so it's trying to adjust what it sees in the scene, and it's trying to adjust that to kind of match what it thinks the values should be right. So it does okay, but we often want to kind of have a little bit more control over that. And one of the ways that we can control that, or the main way that we control that, is to add a post-process volume. So if we search for post-process volume and drag that into our scene, then you may have done this before, but one of the things that we want to change first in this is to search for infinite extent unbound, and we want to check that. That basically just means that everything in our scene is now going to be able to reflect the settings in here. Whereas if we didn't check that, then only what was inside of this volume would be affected. Okay. So if we look under the post-process volume, we have all kinds of different things that we can change here. And this can be quite daunting and a little confusing because this is giving us access to a lot of different settings that are going to affect the camera that we're looking through in the viewport here, but they're also going to affect just all kinds of other settings in terms of lighting, in terms of global illumination, reflections, all kinds of stuff, okay? So the first thing that I want to talk a little bit about is the exposure and the auto exposure. Now we're going to be going into talking way more about this in the future, but for right now, I just want to basically lock our exposure to where it's not changing. And so what I'm going to do is go down here to the min EV and max EV 100 numbers. And you can see by default, they're set to be -10 to 20. This is basically a range that the engine can use to calculate how bright or how dark it needs to adjust the exposure. So if I set this to be the same, then we will have the same exposure. So if I set this to something like 1 and 1, now when I go to adjust this light, then we're not going to get any auto exposure. You know, if I set this to 10,000 now, then it's going to be very bright. And this is going to be a little bit easier to tell kind of what's going on here. Okay. So let's just kind of, again, go back to the point light, and we can see kind of how it is behaving here. And again, it is casting shadows in all different directions, which is very cool, but is also quite expensive in terms of performance. Now, if we go over here and look at some of the settings, we have the intensity, we have the light color, so we can change the color of the lights. Okay. We'll just leave it at white for right now. We also have the attenuation radius, so that you will see is represented by these 3 big circles here, and that radius is basically how much of the scene the light can affect. So the smaller this goes, the smaller area that this light can affect. It's still the same brightness, but it's just how big of an area it can affect. So this is a very good thing to keep in mind, especially when it comes to performance. You know, by default, this is set to be 1000, and that is okay in some scenes, but you might not need it to be that big in a lot of scenes. You might want it to be bigger in some scenes. It just depends. Next, we have source radius. So this is something that is very useful. So if you look at our shadow here, you'll see that the edges are quite sharp. And that is honestly pretty accurate for just if what we had here was just a single point in space that was having a light shine out from that. But something about lights is the bigger the actual light source is, the softer the shadows are going to get. So if we increase the source radius, you can see that it shows how big that light is. And you can also see, look what's happening to the shadows here. They get much softer, right? So again, if we go to 0, we have just this really harsh, sharp shadow. And then if we increase the size of that, if I do this something really small like 5, you can see just it's starting to get softer. If we go up to 10, you can see it gets a little softer. If we go to 25, it gets softer. If we go something really big like 500, then this light is massive. And you can see that you have this really, really soft shadow now. Now, the other thing that you'll notice is the shadows are not super accurate. This is not bad, but we're using virtual shadow maps, if you remember in the settings, and it's doing a pretty decent job, honestly, at trying to calculate what this shadow should look like, but it is not 100% accurate. So first thing I'm going to do, I'm going to lower this because we're probably not going to usually have a light source that is that big. I'm going to set it at 64. Okay, so that's maybe going to be a little bit more accurate there. And you can still see that we have like some kind of weird artifacts here, and this is not super accurate for the shadow. So if you remember, I was talking about ray trace shadows in the project settings. So if I actually search for ray trace, then we can find cast ray trace shadows, and by default that's turned off. So if we enable that, okay, so now you can see these shadows are way more accurate. Very, very accurate in terms of how the light is creating that shadow. And that is pretty cool, honestly. But you also need to understand that this is very, very expensive. Now, I mean, we're still getting 120 FPS here, But, when you start adding a lot of things to your scene and you're having to add multiple objects in here and it's having to calculate the shadows on every one of those, and then it is going to get pretty heavy on performance. So I would use this sparingly and just know that it will give you much more accurate shadows, but there is a cost to that. So I'm going to go ahead and change this back to project default. And actually you can see, let's see if I can toggle it on and off now. Yeah, now that the engine has kind of calculated that we had that on, then we can see much better here what our shadows are looking like with ray trace shadows on versus ray trace shadows off. Okay. So again, this is not bad, especially considering that it's calculating it way faster and it's giving us better performance. And in most cases, that's going to be fine. Okay. So let's go back here and let's see. Let's talk a little bit more about some of the settings here. So we also have the soft source radius is not something that I use much. The source length, so this is very useful. If we increase this, you'll see that this changes the shape of our light here. And this is more like kind of like a tube light now, right? So, I could create something like this, and then we can make this bigger. And this could be something like a fluorescent bulb or something, okay? And then you can also, well, you can't really see very good here, but you can see the shape of the light is kind of reflecting off of the bottom here. Let's actually, let's see, let's create a new material to kind of show some stuff as well, because another thing is materials are going to affect your lights quite a bit as well. Materials. And let's just do something like color. Okay, this is going to be a very basic material here. We're just going to have two different values for our roughness. Let's call this roughness, and we'll call this color. And I'm just converting these two parameters so that I can change them on the fly. Okay, and by default, we'll just set that to be white, and our roughness will set to be 0.5. Okay, now I'm going to also just create a material instance from that, and we'll just call this floor, and then we'll just throw that on there. Then I'm going to open this up, and now I can change some values here. So let's change our roughness. Let's actually set this to 0 so it's really shiny. And there you can see our reflections much better. So again, this the way that we have this set up here would be, something like a fluorescent bulb. And it's pretty cool that the shadows or the reflections are accurately showing that as well. Okay. So let's see. We also have temperature that we can change here. So this is the temperature measured in kelvins. And basically all you need to know with this is the lower this number goes, the more kind of orange-red your light gets. And the higher this number goes, the more blue, kind of towards the blue side of things that the light gets. And there are a lot of different lights that have different temperatures. So something like, even sunlight kind of changes its temperature depending on where it is in the sky. As the sun, when the sun is like kind of, if it's noon, if the sun is up high, then typically you have a temperature that is somewhere around 5,500 to 6,500 Kelvin. But as the sun drops down and you get a much softer, warmer light, then that will, change your temperature. And then as it as the sun goes all the way down and you go more into nighttime, then you actually get like a much cooler kind of bluish light, especially from the moon. So again, we'll go over some of those later, but just know that you can change your temperature right here. And you can base this off of real world lights as well, because you can often look at what a light bulb is and it will say, sometimes it'll just say like daylight balanced. And that usually just means it will be like between 5,500 and 6,500. But sometimes they actually say like, oh, this is a 4,000 Kelvin bulb or something like that. Okay. So the other things here, we can turn shadows on and off, which is very useful. Because a lot of times when we're using point lights, we might want to just use them as more like an area light to just kind of fill in some light. And again, because they are quite expensive, you can turn the shadows off, and that'll make it a little bit better for performance. Now we also have indirect lighting intensity. So this is getting into talking a little bit about lumen and global illumination. But for right now, I just want you to look at kind of the other side of the sphere here. And as we increase this, you'll see that we're getting more light on the backside here. And then as we decrease this, we get less light, okay? Volumetric scattering intensity, this is going to affect the light only when we have volumetric fog in our level. We will go over that later, but just know that that's going to make the kind of the shape of the light that you see in the fog more visible or less visible for that. Okay, so that is really kind of the main settings that I'm going to go over in the lights here. And you'll notice that this is going to be pretty similar for the different lights that we have. But let's go ahead and just delete this light. And let's move on to, let's talk about the spotlight. So we'll drag the spotlight out, and really the spotlight is pretty much exactly what it sounds. It is a point in space that is casting a light, but it is a directional light. So it is just casting it in one direction, whereas as the point light is casting it in 6 different directions. Okay. And now if you look over here, we have similar settings again. So we have our intensity, we have light color, attenuation radius, those are all the same. But then we have these 2 different settings here for the inner and outer cone angle. And by default, there is no inner cone. There's only this outer cone. And you can pretty much see what that does. So that just affects kind of the radius here of how far that is spreading out as we make that bigger. And it is clamped to 80, but you can actually go above that. So you can go to 90 if you want. I don't know if you can go above 90. Yeah, I guess you can. I don't know if that actually works though. Let's see if I go to like 1 and 5. Yeah, so I don't think that that is actually working. Yeah, I don't think that is. Basically, I think this is going to stop at 90. So keep that in mind. And then what you will often see, a lot of times people do, is, as I said, the point light is 6 times more expensive than the spotlight. So what you can often do is just duplicate your spotlight and then flip one of them upside down like this, and basically do something like this. And then if we select both of these, and if we set our outer cone angle to something like 80, then this is going to give us kind of a similar effect to what the point light is doing, but it's cheaper. And then a lot of times you can even set your light that is pointing up. You can turn the shadows off on that because you don't really need shadows in a lot of instances. So that's just something to keep in mind. Now we do have the inner cone angle as well. So if we start increasing that, then you'll see that we get this other set of lines that are coming out. Okay, and basically what this is affecting, if I just turn this up a little bit brighter, it's kind of directing the light a little bit more towards the center. So right now the light is pretty focused towards the center, but if I increase this, you can see that the light is kind of spreading out a little bit more. And there's no right or wrong values for these. These are really just a personal preference and an artistic preference, and just are going to vary scene by scene. Okay, so keep that in mind. All right, now we also have source radius for this as well, which is really nice. So we can increase the source, and you can again see our shadows get softer as we do that. And then you can also increase the length as well. So you can actually create very similar to what we did with our point light. I mean, this is basically, if we're just looking, at like this angle right here. By the way, I'm toggling the gizmos and everything on and off just by hitting the G key on the keyboard. But you can see this is basically the same thing that we did with the point light. And this is way more efficient to use this than to use that point light. But again, there's sometimes where you want a point light or where you need a point light. It just depends on the specific scene. All right, and pretty much everything else is the same. You still have temperature, indirect, all that stuff. All right, so let's delete that and let's move on to the Rect Light. Now, the Rect Light is very fun for me because as a photographer, this behaves very much like a softbox. And if you've ever used a softbox or seen a softbox, or if you've ever had your picture taken with a softbox, or if you're a photographer and if you've ever used softboxes, you know that we love them because just as they sound, they create very soft lighting. And they do that by taking a single point light, or spotlight technically, and they often will shine that light through some kind of diffusion material, or sometimes they even turn the spotlight around and bounce it off the interior edges of a spotlight, and then it goes through an additional layer of diffusion. And so basically what it is doing is just creating a very soft light. And the larger your light source is, the softer that light is going to be. So you can see here as I increase the size of this, now it's actually not changing that much. That's probably because we are using non-ray trace shadows. Let's see if we turn it on, if it will be more accurate. Let's try and turn this on. Okay. And let's reset this. Okay, so now if we increase, okay, yeah, so you can see this is one of those instances where ray trace shadows are going to give us much more accurate lighting. So you can see as I make this light bigger, this light is massive now. That shadow is almost gone because we just have such soft light that we're putting out that you don't really have much of a shadow. You still have like you do have a shadow back here, but it is just providing so much light that is hitting all of this and bouncing all around that we get this really soft light here. Okay, now this light is quite expensive as well in terms of performance, so keep that in mind. And let's also turn ray tracing off again. All right, let's set it to project default. Okay. So yeah, our source width and height, those control the size. We still have all of our other settings here. The one thing that is a little bit different are these barn doors. So the barn doors are kind of the side of this. And you can see as I change the angle of this, then this becomes just like basically a straight rectangle now, or square. And then if I open this up a little bit, then we're just spreading out the light to the sides more and more. And we can go all the way up to 90. And then we can also change the length of that as well. Okay. So one cool thing you can do, if you wanted to have like a really like a really direct, like directionally light, you could do something like this, where you have this very large barn door, but you have it pointing right at your subject, and then you're going to see you kind of have like this sharper cutoff here on the sides, because this light is going through almost like a tube, right? And it's being restricted on how much it can spread out. So this is kind of an exaggeration, but sometimes you might want to do something like that. So that's just something to keep in mind. And that is pretty much it. Again, we have our temperature, we have cast shadows, indirect lighting intensity, and all that stuff. So those are our three main lights that we use in the engine. Actually, so there is one other thing, very important thing that I want to talk about, and this is the same for all the lights, but there's a lot of confusion about how the mobility of the lights is set up here. And to be honest, I don't know why Epic still has these defaulting to stationary, because these are really only going to be useful if we're using baked lighting, and we're not using baked lighting. So for really every light that we're going to be using up until we talk about baked lighting, we're going to just want this to be movable. Okay. Essentially, what a static light is, this would be used for baking the lights. And if you were to set this as a static light and you had allow static lighting to be turned on and you baked your lights, if we baked our lights here, if I moved this sphere, if I move this sphere after we baked the lights, then this shadow would just stay there, because baking lights is essentially just creating a map of whatever the mesh is here, and it's basically creating like a texture on top of the mesh with the lighting information kind of baked into it. Now, again, right now we're not going to be using baked lighting, and by default, Unreal Engine is set up to not really use baked lighting. So stationary lights are kind of a combination of baked lighting and movable. They allow you to bake some of the information in here, but they still allow you to cast real-time shadows. So like we could bake this scene with a static light, and it would bake the lighting information in here. But then if we walked through here and our character was casting a shadow, you would still see our shadow with that. Okay. And then movable is just everything is using real-time lighting, and there's no baked lighting information in here. And that's what we want, and that's what we're going to use. And again, there's really no reason for you to set any of your lights to be on static or stationary if you're not doing baked lighting, okay? So every light should just be movable. So I hope that clears that up. I know I see so many people confused about that, and I was confused about that for a very long time. Again, I think Epic does not do a very good job at explaining that, and I don't know why they have it default to stationary, because it just doesn't really make sense. So every light is basically going to be a movable light when we are working with real-time global illumination and Lumen. All right, so those are our three lights, our three main lights anyway. Now let's go ahead and talk about a little bit more of the specialty lights, which are the directional light and the skylight. So the first thing I'm going to do is talk about the directional light. So if I drag this in, first thing you're going to notice is everything is super bright. And let's actually just turn this down a little bit. Okay, so the way to think about the directional light is this is essentially the sun, okay? So the sun in real life is extremely bright, and it is just a point in the sky that does move, but it is a pretty much a fixed point in space. Now again, we want to change this to movable, not use static or stationary. And the first thing that you're going to notice over here in the details is under our intensity, we have a different unit here. We're using something called lux instead of lumens. And the reason for that is because the directional light, aka the sun, is so bright that if you were to try and measure the lumens in sunlight, it would be like such an astronomically large number that it just wouldn't even have any meaning. So we use different terminology for the way that we measure the light from the sun, and the light from the sun is measured in lux. Now, we're not going to get too much into real world numbers in this episode. We'll go into that, I think, in the next one. But just know right now that these numbers are very, very, very far off. And this is because we're not using physically based lighting numbers right now. But the sun, I believe, I'll have to look it up, but I believe the sun during like bright sunlight is usually around 100,000 lux. So that's really, 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 really bright. If we did 100,000, then you can see like that just pretty much blows out everything, right? So again, we're going to talk about how to actually use those numbers and get our scene set right, but we're going to save that. Right now, I just want to kind of cover what these different lights are and a few kind of details about them. All right, so we again have kind of the same things here. We have the intensity with the light color. We have the source angle and the soft source angle. So this is kind of like the size of our light. But actually, before I go into that, let me also just talk about how we move this. So you can see right here, it doesn't change our shadows whenever I move this. That's because, again, this is replicating or trying to replicate a sun. And the way that we move this is hold Control and the L button on your keyboard and just keep holding those. And then you'll get this little thing that pops up. And then you can actually move your sun around, okay? So you can even see the reflection of it up there. So I just want to try and move it to where we get a little bit longer shadows here. All right, so if we wanted to increase the softness of our shadow, then sorry, I said this wrong, actually. The source angle is going to adjust the softness here. So as I increase this number, we're going to get softer shadows. And you can actually see the size is getting larger there as well. Now, I usually don't change this very much. And the reason for that is because this is honestly pretty accurate. If you ever go out on like a sunny day and you look at if you look at your shadows from like yourself or just anything really, the shadows are actually quite harsh. They're pretty sharp on the edges, and the reason for that is kind of technical, but essentially what you need to know is the further a light is from the subject, the harsher the shadows are going to be, the sharper the shadows are going to be. I might can even demonstrate that. Let me just grab a, let's see. Let's get a Rect Light. Or actually, let's just use a point light. Okay. So let's also change the source to 25. And I'm also going to turn ray tracing on for this so that we get really accurate shadows. Okay. All right. So what I want you to look at, so I'm going to increase this a little bit. Okay. So as our light is closer, then we have very soft shadows, right? But what I want to try and show here, this might be kind of hard, but if I bring this further away, and if I increase our attenuation radius, okay, this is actually showing pretty well. So you can see that the shadows get sharper the further this goes away. And this may sound like counterintuitive. I know it did for me when I started doing photography. I was like, I don't really get that, but this is just kind of the science of lighting. So as we get closer, the shadows get much softer. Now you'll see that the light gets brighter. That makes sense, right? But this is just how lights work. When the light gets closer to a subject, the shadows get softer, and when it gets further, they get sharper. Okay, so if you can imagine the sun is massive, right? But it is really, 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 really far away. It's way further than any light that we have on Earth, right? So that is why, when we turn this back on, we have quite harsh and sharp shadows from our sun, and that is fairly accurate as well. Now, I don't know, let's see, if we turn ray tracing on, yeah, you can see that that's actually even more accurate, so that's like even a little bit sharper there. And then if we increase this, it does get softer, but again, that's not really realistic. So the default value they have here, I don't really know how that's calculated, to be honest. I don't know how accurate that is. I would say just from my personal experience of taking photos especially at weddings during the middle of the day, that looks pretty accurate. Like there is a little bit of a fall off at the edge of a shadow. And, you know, the taller this gets, then the longer the shadow is going to get and the softer that's going to get. So that seems pretty accurate to me. So I would probably just kind of leave that at the default value for the most part. But yeah, so let's turn ray tracing back off. Okay. All right, so I think that's kind of everything that I want to cover about the directional light for the time being. We're going to go much more into this. Again, you still have your settings for casting shadow, volumetric scattering intensity, indirect lighting intensity, that kind of stuff, but that is pretty much it. So let's delete that light and let's talk about the last light, which is I think maybe this is the light that gives the most people confusion. So the first thing that you notice whenever I drop the light in here is nothing happens. And I'm going to go ahead and set this to movable. The reason that nothing happens is because the way the Skylight works is this needs additional information to calculate what the lighting should look like. And you'll notice that by default, it's set to not be real-time capture. And if I check this, then we'll get this error message, and we'll see that it says a skylight with real-time capture enabled is in the scene. It requires at least a sky atmosphere component, a volumetric cloud component, or a mesh with a material tagged as is sky. Otherwise, it will be black. So what is that saying? It's saying that it needs additional information to calculate what this light should look like. And what the Skylight is doing is it's kind of representing like a little bit of the atmosphere, the way that the light, obviously if you were to go outside and the sun just disappeared, there would not be any light. But if you can imagine that we were to cover up the sun and we still had light kind of coming in from the sun, but it wasn't like that direct light, there would be like this kind of soft light that would fill the scene that we're in, and it wouldn't be necessarily nearly as bright as the sun, but it would give us like a really soft kind of light in the shadows and everything like that, right? So that's kind of what the Skylight is doing. But again, it needs information to know how to affect the scene. So one of the ways that we can do that is we can use the sky atmosphere and the volumetric clouds. But one of the best ways that you can do this is to actually use an HDRI. And what an HDRI is an actual real world photo. And it's kind of like a 360 view of a sky or sometimes an entire scene. And we can feed that information into the engine, and then we can have the Skylight capture the information from that and reflect that in our scene. So the way that we can show that, if we go to the engine content, now you'll need to enable show engine content right down here. So go to the settings, show engine content, and if we search for HDR, let's see, we only have one, is that right? Okay, so I'm gonna actually find a few more. Or I tell you what we can do. Let's actually go to plugins. There's an HDRI plugin that we can enable. Let's enable this. We'll need to restart, and I'll be right back when we get this restarted. Okay, so we got restarted here, and let's open up our previous level. I don't know why that's defaulting to cinematic. I'm going to change that back to high. And okay, so we've got our skylight in. Now we have the HDRI content. So let me kind of explain what this is. Actually, I'm going to delete the skylight. And if we just search for HDRI, we have an HDRI backdrop that we can bring into our scene. And we're going to get this. Okay, so now what you're seeing is actually, if I zoom way out, this is actually just a mesh, kind of like this dome mesh that we're getting. And then it's taking this image. So it's taking this image, which is a real life photo, and it's mapping that to the inside of this. And then when we go in here, we're actually seeing this. So you'll see that it is not doing a very good job at lighting our scene at all. I believe that is because the size is way too small. Yeah, there we go. So we need to make this way bigger in the size right here. And now you can see this is actually looking really good, right? This is giving us pretty, I would say, pretty accurate lighting to what this scene looks like in terms of this daylight scene here. We've got, you know, the sun is really kind of behind the clouds there, so we're not going to have too much of a shadow, and we would have pretty soft lighting for the most part. So this is actually pretty accurate. Now, this is fine to use this, but I like to basically create my own HDRI backdrop. And there's a couple of reasons for that. If you look in here, what we have in here, it's essentially just a geometry, which is this mesh, and then we have a skylight. And I like to just be able to control this a little bit more and just be able to control all of the settings more. So I'm going to show you how to basically create that. So what we can do is, again, in our engine content, if you just search for editor, let's see, sphere, I think it is. Yeah, the editor sphere here. So I can drop that in. And then we can create a material. So let's go back to my content, materials. Let's create a new material called sky. Let's actually call it m_sky. And let's open that up. And this is going to be a material that we're going to apply. I'm just going to go into unlit here. So we're going to apply this to this sphere here. And in order to do that, we need to change a couple of things. So under, let's see, under the shader model or shading model, we need this to be unlit. And then we want this to be two-sided because we're actually going to be on the inside of this. And so we want to be able to see the material that we're going to put on here. All right, now we need a couple of things. We need an actual image. So if we go back here and search for HDR, then I think, let's see, I think they're using that one. So I'm going to grab that one. Now, I can't just plug this directly in here like this, because you'll see down here, it requires a UVW input required for the cube map sample. Essentially, it needs to have something calculate the position of the UVs for it here. So to fix this, we can just get an absolute, let's see, world position. We can get this and just plug this into our UVs, and then this will work. The other thing that we need is we need an intensity for this. So I'm just going to hold 1, and I'm going to create a vector, convert this to a parameter, and we're going to call this, let's see, HDRI intensity. And for right now, I'm just going to set this to 1. And then we'll multiply this like this with our texture, and that will go into emissive. Okay, so now if we apply, and now if we go back to our level here, we can get this material and apply it to our sphere. Okay, and then we have this. And now we need to basically make this way, way bigger so that we go inside of it like this. Okay. And we're going to want this to be huge, really. So I'm going to lock my scale here, and I'm going to set this to something like 15,000. Okay. So this is going to be massive. Now, you can see that the light looks pretty good, looks pretty accurate, but we don't have any information on our actual scene here. And that's because we don't have our skylight. So we need to add our skylight back. So let's get that. And now you can see, honestly, that looks pretty good just as is. If we take a look, so, okay, so one thing that we need to, well, we want to set that to movable first. And then the other thing to know about the skylight is, since we don't have real-time capture turned on, in order to actually get the changes to be affected, we need to sometimes recapture it right here. So it looks like it already did calculate and recapture everything, so we're good. But sometimes you might notice that you'll make changes to something. Let's see, actually, if we go in here and if we set this to something like, I don't know, 1,000. Okay, so obviously this is really bright here, but I don't think that we have updated our scene here. So if I recapture, then yeah, you can see that this is now updated, and obviously this is way too bright. So I'm going to set that back to 1, apply. And then again, you can see here, like, we didn't actually update this. So we need to go back here, recapture, and then we're going to recapture our scene information there. So to kind of recap, our skylight is a light. It's a very special kind of light that needs additional information to calculate the light that it's going to put off. And it's going to put off kind of like this atmospheric light for us that is going to help fill our scene, but it's not going to be an actual directional light. So we would still need to add in, you can see that our sun is over there, but we're not actually casting any shadows here. This kind of looks like a shadow, but it's really just more of a reflection. Let me actually just open this up, and let's bring in a little bit of roughness so that we don't have just those really harsh reflections there. All right, so let's add back in our directional lights. Now, you're going to see that we've got kind of some weird things going on here, right? So if I come in close, we can see our shadow, but if I zoom out, we get like this weird kind of effect here. The reason for this is because if we look at our skylight, there's this sky distance threshold, and my understanding, could be wrong about this, but I believe that our editor sphere, whatever our HDRI is projected onto, it needs to be the same size as this. So if I copy that with Control C, and if I go here and if we set the size to that, then this is looking correct. Okay. So yeah, I don't fully understand what this is doing. I think it's basically saying, let's see what it says here. Distance from the skylight at which any geometry should be treated as part of the sky. This is also used by reflection capture. So update reflection capture to see the impact. So I don't know, maybe we need to also recapture here just to make sure that that's right. But I think essentially what it's saying is that anything smaller than this is not being treated as the sky, and anything that is this size or bigger is going to be treated as the sky. So we want our editor sphere to basically be our sky, so it needs to be that size. Could be wrong about that. I'm not 100% on that, but that's kind of the way that I understand it. And if I set my physical scale of the sphere to that, then it seems to work right. Okay. All right. So now we have our skylight in. We have data that is captured from a real photo to give us real kind of lighting conditions. And then we also have our directional light, which this is not very accurate now because, you know, if you look at our scene, we have our sun over there and it's quite hidden behind clouds. So first of all, we need to rotate our sun to where it is facing more in that direction. We would want it, you know, kind of like around there, I would say. And then I would argue that this is probably way too bright because we shouldn't really be seeing these shadows. So we would need to go to our directional light and we would need to lower this quite a bit. You know, maybe something like 0.5. You still probably would have a little bit of a shadow, but it wouldn't be quite as harsh. And this also might be a case where you do want to change the source angle because this would be a much softer shadow that we are casting, because much like the softbox, we now have the sun coming through what is essentially a softbox, which is a giant cloud. And so it's going to give us softer shadows. So this is just one of those things where you kind of have to play around and test it out, but you're going to have pretty soft shadows if you even have a shadow here at all. And this is again where in the future we're going to be talking about physical based lighting values, and this will make a little bit more sense. This is going to be like a much higher number when we get those set up, and it's going to be more accurate, and we'll be able to actually look up real world data to calculate this stuff. Okay, so I think that is where we're going to wrap it up for this episode. We've covered quite a bit. We went over the basics of our kind of 3 basic lights that we use in Unreal Engine. And then we also kind of dipped our toes into the directional light and the skylight, which is quite complex. There's a lot more that we have to talk about those. But for the time being, I just wanted this to be kind of an introduction to those. So I hope you guys found this useful. We've got a lot more to cover in the future episodes, so I hope you guys will come back for those. And if you guys have any questions, as always, feel free to leave them in the comments below. And I hope you guys have a good rest of your day or night, and I will see you guys on the next episode. All right, take care, guys.